Beyond the stars and far from any planet, there are objects floating in the vast emptiness of space that should not exist. These are not the usual asteroids or comets we expect to find. They defy our understanding of physics and challenge what we think we know about the universe. In this video, we are diving into the mysteries of these bizarre space objects. Get ready to question everything you thought was possible. Space is vast and full of mysteries. Sometimes, astronomers find things they didn't expect to see. These unexpected discoveries can challenge our understanding of the universe. One such discovery is exoplanets in the Neptune desert. This is a region close to stars where planets shouldn't exist because the heat and radiation from the star should have stripped away their atmospheres. Yet, there they are, defying expectations. Another intriguing find is rogue planets. These are planets that don't orbit a star. They roam freely through the galaxy. This is unusual because most planets we know of orbit a star. Rogue planets challenge our ideas about how planets form and behave. Some of these rogue planets are even thought to have been ejected from their original solar systems, adding another layer of mystery. Then there are the impossible galaxies. These are galaxies that seem to have formed too early in the universe's history. They are massive and mature, which shouldn't be possible given the age of the universe at that time. These galaxies push the boundaries of our understanding of galaxy formation and evolution. They suggest that the early universe might have been more complex and active than we previously thought. Lastly, there are the mysterious fast radio bursts, FRBs. These are intense pulses of radio waves that last for just a few milliseconds. They come from faraway galaxies, and their cause is still unknown. Some theories suggest they could be caused by neutron stars or black holes, but their unpredictable nature makes them difficult to study. FRBs are a reminder that there's still much we don't know about the universe. In the vast expanse of the universe, there are objects that seem to defy our understanding of physics. These celestial bodies challenge the very laws that govern mass, speed, and composition. Among these enigmatic objects are neutron stars, which are incredibly dense. A single sugar cube-sized amount of material from a neutron star would weigh about 1 billion tons on Earth. This incredible density is a result of the star's core collapsing under its own gravity after a supernova explosion. Some objects in space exhibit speeds that seem impossible. For instance, certain particles in cosmic rays travel at velocities approaching the speed of light. These particles, often protons or atomic nuclei, are accelerated to such high speeds by astrophysical processes that are not yet fully understood. Their speeds are so great that they can traverse vast distances in relatively short periods, making them some of the fastest moving objects in the universe. Compositions of certain cosmic objects also defy conventional understanding. Quasars, for example, are extremely luminous active galactic nuclei. They emit enormous amounts of energy, often outshining entire galaxies. The energy output is so immense that it challenges our current models of how energy can be produced and emitted in the universe. Similarly, dark matter, which makes up about 27% of the universe, does not emit, absorb, or reflect light. Its existence is inferred through gravitational effects on visible matter, making it one of the most mysterious compositions in the cosmos. Moreover, there are objects like black holes, which have a gravitational pull so strong that nothing, not even light, can escape. The concept of a singularity at the center of a black hole, where density becomes infinite, is a point where the laws of physics as we know them break down. These objects push the boundaries of our understanding, prompting scientists to continually refine and expand our theories of the universe. The cosmos is filled with objects that challenge our understanding and defy easy categorization. These celestial bodies often blur the lines between different classes, leaving scientists scratching their heads. Take, for instance, the object known as Thelonious Monster. This peculiar entity exhibits characteristics of both a comet and an asteroid. It has the rocky composition of an asteroid but also displays a tail-like feature, typically associated with comets. Such objects force astronomers to question and expand their classification systems. Another intriguing example is the Manx objects, also known as disrupted or fragmented comets. These objects appear to be comets that have lost their tails and, in some cases, their nuclei. They don't fit neatly into the comet category anymore, nor do they fit into the asteroid category. Their existence suggests a continuum between comets and asteroids, rather than distinct, separate classes. This challenges the traditional view of these celestial bodies as entirely separate entities. Furthermore, there are objects like Oumuamua, the first known interstellar object observed in our solar system. Its elongated shape and unusual trajectory defied classification. It didn't fit the typical profiles of comets or asteroids, leading to speculation about its origins and composition. Such objects push the boundaries of our knowledge and force us to reconsider our understanding of the universe. They serve as reminders that the cosmos is vast and full of surprises, with many more mysteries waiting to be uncovered. When astronomers and scientists observe objects in space, they expect to see certain behaviors based on our understanding of physics and the universe. However, some objects exhibit movement and changes over time that challenge our expectations and current understanding. Take, for instance, Oumuamua, the first interstellar object observed in our solar system. It exhibited unusual acceleration as it moved away from the Sun, which couldn't be explained by gravitational forces alone. This unexpected behavior led to speculation about its origins and composition. Some scientists even suggested it might be a thin slice of a larger object, perhaps a nitrogen iceberg, which would explain its unusual acceleration due to outgassing. Another intriguing example is the distant star known as Tabby star, or KIC 846-2852. This star exhibits irregular dimming patterns that can't be easily explained by any known astronomical phenomena. The changes in its brightness over time are dramatic and unpredictable, with dips of up to 22% that last for days or weeks. Theories range from massive dust clouds to alien megastructures, but the true cause remains a mystery. The star's behavior challenges our understanding of stellar activity and the nature of orbiting bodies. Similarly, some fast radio bursts, FRBs, exhibit repeating patterns that are difficult to explain. FRBs are intense pulses of radio waves that last for just a few milliseconds. While most FRBs are one-off events, a few have been observed to repeat. The changes in their pattern and frequency over time are puzzling. It's like trying to understand a message in a code that keeps changing its rules. These repeating FRBs could provide valuable clues about their origins, but their unpredictable behavior makes them difficult to study. When scientists encounter anomalies in space, they often propose explanations to understand these puzzling phenomena. However, not all theories stand the test of time or scrutiny. Some hypotheses are eventually rejected due to lack of evidence or inconsistencies. These rejected explanations, though initially promising, fail to provide a coherent understanding of the observed anomalies. One such case involves the WOW signal, a strong narrowband radio signal received in 1977 by Ohio State University's Big Ear Radio Telescope. Initially, some speculated it might be a sign of extraterrestrial intelligence. However, despite extensive follow-up observations, the signal was never detected again. Various natural and human-made sources were considered, but none could be confirmed. The inability to reproduce or explain the signal led to the rejection of the extraterrestrial hypothesis, leaving the WOW signal as one of the most enduring mysteries in the search for extraterrestrial intelligence. Another example is the Fermi paradox, which questions the contradiction between the high likelihood of the existence of extraterrestrial civilizations and the lack of contact or evidence for such civilizations. Several theories have been proposed to resolve this paradox, including the zoo hypothesis, which suggests that advanced extraterrestrial civilizations might be deliberately avoiding contact with Earth. However, this hypothesis lacks empirical support and remains speculative. The zoo hypothesis, along with many other proposed solutions to the Fermi paradox, has been largely rejected due to the absence of concrete evidence. In the vast expanse of space, there are objects and phenomena that challenge our current understanding of physics. These anomalies have led scientists to propose new ideas and models that push the boundaries of what we currently accept as true. One such proposal is the concept of dark matter and dark energy. These invisible entities are thought to make up a significant portion of the universe, yet they do not fit into our existing models of particles and forces. Dark matter is believed to be responsible for the gravitational effects observed in galaxies and galaxy clusters, while dark energy is thought to be driving the accelerated expansion of the universe. Another intriguing idea is that of extra dimensions. Our everyday experience suggests that the universe has 3 spatial dimensions and 1 time dimension. However, some theories propose that there could be additional, hidden dimensions that we are not aware of. These extra dimensions could be incredibly small or tightly curled up, making them difficult to detect. If they exist, they could help explain why gravity is so much weaker than the other fundamental forces and could even provide a framework for unifying all the forces of nature. Some physicists are also exploring the possibility of alternative theories of gravity. General relativity, which describes gravity as the curvature of spacetime, has been incredibly successful in explaining many phenomena. However, it struggles to account for the behavior of gravity on very small scales or in extremely strong gravitational fields. Alternative theories, such as modified Newtonian dynamics, MOND, or loop quantum gravity, aim to address these shortcomings. These theories suggest that our understanding of gravity might be incomplete and that there could be new, undiscovered aspects to this fundamental force. Moreover, the concept of quantum gravity is another frontier in physics. Quantum mechanics and general relativity are two of the most successful theories in physics, but they are fundamentally incompatible. Quantum gravity aims to reconcile these two theories, providing a single framework that can describe the behavior of the universe at both the smallest and largest scales. This could lead to a deeper understanding of black holes, the early universe, and the nature of spacetime itself. While these ideas are still speculative, they offer a glimpse into the exciting possibilities that lie beyond our current models of physics. In the vast expanse of the universe, astronomers are constantly making new discoveries. However, some of these findings have sparked intense debates and divisions among researchers. The mystery objects and phenomena that defy our current understanding of physics and astronomy have led to heated discussions and differing interpretations. One of the most contentious topics is the existence of Oumuamua, the first known interstellar object observed in our solar system. Some researchers argue that its unusual shape and trajectory suggest it could be an artificial object, possibly a solar sail from an advanced civilization. Others firmly believe it to be a natural object, perhaps a hydrogen iceberg, and caution against jumping to extraordinary conclusions. This division highlights the challenge of interpreting unusual observations with limited data. Another point of contention is the existence of fast radio bursts, FRBs. These are intense pulses of radio waves that last for a few milliseconds. While most astronomers believe they are natural phenomena, possibly linked to magnetars or neutron stars, some suggest they could be signals from extraterrestrial civilizations. The lack of a definitive explanation has led to ongoing debates. Furthermore, the discovery of Tabby star, or KIC 846-2852, which exhibits unusual dimming patterns, has also sparked controversy. Some hypothesize that the dimming could be due to a megastructure built by an advanced civilization, while others propose natural explanations like dust clouds or internal stellar processes. Despite numerous studies, the true nature of these objects remains elusive. Objects in space that defy our current understanding of physics and astronomy challenge the very foundations of our cosmic knowledge. These anomalies, often referred to as impossible objects, force scientists to reconsider long-held theories and models. For instance, the discovery of ultra-compact massive galaxies has baffled astronomers. These galaxies are as massive as the Milky Way but fit into a space as small as the distance from the Sun to the nearest star. This defies the typical size-mass relationship that galaxies usually follow. Such findings suggest that there might be unknown physical processes at play, reshaping our understanding of how galaxies form and evolve. Moreover, the existence of rogue planets, which are not bound to any star, has significant implications. These wandering planets, untethered to any solar system, challenge the conventional view of planetary formation. They suggest that planets can form independently of stars, a concept that was once considered implausible. This new understanding forces astronomers to revise their models of planetary formation and distribution in the universe. The implications are profound, as it means there could be many more planets than previously thought, some of which might harbor life. Another intriguing anomaly is the existence of ultra-diffuse galaxies. These galaxies are as large as the Milky Way but have a fraction of the stars. This low density makes them incredibly faint and difficult to detect. Their existence challenges theories of galaxy formation and dark matter distribution. Scientists are now exploring whether these galaxies are formed from the merger of smaller galaxies, or if they are the result of an unusual interaction with dark matter. The study of these galaxies could provide crucial insights into the nature of dark matter and its role in shaping the universe. These objects, among others, are not just curiosities, they are game changers. They push the boundaries of our knowledge and force us to question our assumptions. Each discovery opens up new avenues of research and challenges scientists to think outside the box. As our understanding of these anomalies grows, so too does our comprehension of the universe. This continual process of questioning and discovery is what drives the field of astronomy forward, ensuring that our cosmic understanding is always evolving and expanding. As we wrap up our journey through these cosmic oddities, let's recap the incredible objects we've encountered. From the mysterious Black Knight satellite to the enigmatic Tabby star, and the puzzling Impossible comet, space has certainly given us a lot to ponder. These objects challenge our understanding of the universe and remind us that there's still so much we don't know. It's like having a cosmic detective case on our hands, and the thrill of the unknown is what makes this journey so exciting. So, keep looking up at the night sky, because the universe is full of wonders waiting to be discovered. And remember, we are always here to explore these mysteries together. Stay curious, and don't forget to subscribe for more mind-bending adventures into the great unknown. Until next time, keep your eyes on the stars.